Well, hello there. It is KP the Math G here. I guess you didn't think I'd ever come up with another video. This would be my 136th video as of, well, this one right here. I've got a little something for you. I want you to see this. Alright. Okay, here we go. Yeah, that's it right there. This is a KP, the Math G. I need to find some smaller letters somewhere and put the Math G down, but this is good. I like KP, so I'm gonna wear this hat. I think every time I do a video now from this point on. We're doing a 2025 free response question number 1, and we're going to do part C and D today. I apologize. We've been traveling. It's not quite officially summertime, but we've been traveling and seeing grandkids and so on, and busy out in the yard. Of course, well, actually, we've been trapping a lot of animals that come into our garden, and we've caught 11 so far. 5 groundhogs, 4 raccoons, and 2 possums. Okay, well, anyway, be that as it may, we've been kind of busy, and I apologize, but I am going to get back on doing these on a regular basis, so please bear with me, and I appreciate your patience with me. Alright, here we go. Rainwater flows into a drain pipe at a rate modeled by R at T is equal to 20 sine at T squared over 35. On the interval, T between 0 and 8, including 0 and 8, where T is in hours. The pipe allows water to drain out. Alright, so drain out at a rate modeled by D at T is equal to 0.04 T cubed plus 0.4 T squared plus 0.96 T. There are 30 cubic feet of water at T equals 0. And I do have a flashing bulb. I hope it stays on. Stay on. Okay. Part C. At what time T is the water in the pipe a minimum? So, this is amount of water. Okay. This is amount. Okay. Has to do amount of water. So I want to look at this. There's water going into the pipe, water flowing out of the pipe. So at this point, we know that there are 30 cubic feet. So at this point, we're going to say 30 plus, this is the initial amount. Okay, I wish that would stop doing that. I put a new bulb in there not too long ago. Okay, now we are going from at some point T, we're going to start at 0 and go to T. Alright, now at this point we're going to say R, and we're going to put it in something different other than T, and minus. Always remember that when you have water flowing out, I think this may be an X. Let me see. I want to look at that just to make sure. It is dx. Yes, it is dx. Yes, of course, if you start off with dx. And I don't know why I did T here. That's what threw me off. Okay, well, dx. There we go. Okay, if you have a dx, it's going to be dx here. Has relation to this here and this one here. Always remember that water flowing in minus water flowing out. Okay, that's how much is left. Okay, you already have 30. Now what do you want to do with this? Now you remember This is amount, total amount. So we might say, I want to just say A at some t, alright, like that. Alright. What I want to do is, I want to take the derivative of both sides. Now, why would I want to take the derivative? Let me do it this way. Alright, now, why do I want to do that? That's exactly right, because I'm talking about a minimum. If I were talking about a maximum, I'd do the same thing. So when we take this derivative, what's this going to look like? Well, the derivative of 30 is 0. And remember that by the fundamental theorem of the calculus, all you're doing here is, this is just simply saying r at t minus d at t. And all you're doing is substituting the t in place of both x's here, and that's basically it. Okay. Now, of course, it's a minimum, so if something is a minimum, and say t and then a at t, alright, so it's going to have a horizontal tangent, alright, so that slope m is equal to 0. We want this to be equal to 0. So in this case, now we have r at t, and I'm going to bring this to the other side, and that's equal to d at t. We want that to be equal. Now, what I did to get this, I simply went to y equals. You want to make sure that you have these already. I've got a y sub 0. You may start off with y sub 1 and y sub 2, whatever. I'm doing y sub 0, y sub 1. I put this one in y sub 0 and this one into y sub 1. And of course, after you put that in there, you graph it. And I have a graph, and there is a place of intersection somewhere after, I don't know if you can see that. Okay, let me see if I can, I don't know if you can see that at all. But there is a place of intersection there somewhere after t equals 3. Alright. Now, remember, when we talk about a minimum, before we get into this, I'm jumping ahead of myself. So what I want to do is, I want to see where these two lines intersect. Alright, since they're equal, I want to see where they intersect, and I'm only interested in the x value. So let me flip this over. Alright, so okay, let's put this up again. Now, remember we said that r at t is equal to, I want to say that's 20. Alright, so 20 sine of t squared over 35. Now, you might want that in your, I have y sub 0. y1, alright, that's going to be your d at t. And of course, you're just going to put that in. I'm just, okay, so d at t, okay, which is equal to, let's see, d at t, okay, so negative 0.04 t cubed, alright, plus 0.4 t squared plus 0.96 t. Alright. And when I set this one equal to this one, we just observed that r at t minus d at t is equal to 0. When I solve for, well, we're not solving, we're just saying, let's say they're equal. Alright. So when that's equal, okay, now I want to intersect those lines. So when I hit graph, and then on my calculator I can just hit intersect, okay, and you're only looking at the t value or the x value, so t is about equal to somewhere along, to me now, I get 3.27166, and I think the author here, the one who did this, gets 3.27168, and I am assuming that I put this in totally correctly. Let me look again on my y equals. I don't see anything I did incorrectly, so I'm just going to let it be. It's pretty close. It's close enough. And so that is one, that's t. Now you want to find that, but of course what you're interested in now, you got to remember, when you are doing a problem like this and you're finding a maximum or a minimum, and actually what you're looking for is an absolute maximum or an absolute minimum on the interval. In this case, t is between 0 and 8. So we're looking at the two endpoints, and we're looking at this one. So we have t, and in my case I'm putting a at t, whatever you want to call that. Alright, so that. Alright, which is really r at t minus d at t. This is 3 point, let's see, this is 1, so we have a 0, and we have this number, this t here, 3.27166 maybe, and then I also want to put 8. Bear in mind that you're plugging that into each one of these. So first of all, a at 0 is 30 plus, now from the interval 0, well, we're going from 0 to 0, and it is r at, and we also had x, r at x minus d at x, dx. Remember, that's what we had before. We're plugging that into that. Of course, when your integral goes from 0 to 0, all of this becomes obviously what? This is 0, so this is 30. So that's just the initial value. We should know that. Okay. This just says amount of water in the pipe. I'm putting amount here. A is amount. Okay. The next one, we do want to put a at 3.2727166. Alright, I'm going right here doing that, 3.27166. And remember, you can do this in your case. I have it y sub 0 and y sub 1 like that. I can do that, remember. That's what I have here, up here. Okay? When I do that, now we've got to remember it is 30 plus. Okay? So don't forget your 30 in that. You got to add 30 to that. Alright, so in this case here, I already have the answer. Let's see here, hold on. Let's see if I can find it again. Let's see here. Alright, yes. When I plug in this value here, I get something of, let's see, I'm going to put this in green. Well, it doesn't matter. We put it in red. It really doesn't matter. Okay, so I get 27.965. 27.965. Well, we already know we can count this out because this is smaller. We just want to see now what we get at 8. And I think when we did 8, we got 48.544. So 48.544. It's immaterial now because right here is what we're looking for. Now you don't want to leave it like this. Okay, you really don't want to leave it like this. You want to kind of say the amount of water. Now let's put something down. Okay. Remember, you're plugging it back into the amount. Okay, always remember that. Okay, like that. Here we go right here. Let's put it in a different color so everything doesn't look the same color all the time. The amount of water is a minimum at T equals 3.27, if you want to go to 2 like that, hours. Okay, right there. And that's, yep, you might want to say hours. Okay, like that. Alright, there it is. And that's really what you want to do with that. That's, basically you would like to remember that when you're dealing with a maximum and a minimum, you do want to, you're looking for absolute max, absolute minimum. So you got to find that. You need your critical point. That is when R at T is equal to D at T. And then you have the two graphs and you see where they intersect. When T is equal to 3.277, I don't know why my calculator is showing that. I do know that others are saying 1658, but that still rounds up to 2 right there. That would be enough. 3.272. You could do that, okay, or 3.271. You can truncate. But that's that one there. Very quickly, I think we have time to do D. So let's look at that as well. Alright, let's erase that. Oh, I should have left that up there. That's okay. Alright, so alright. This may take a little time to put this up there, but we'll go ahead and do it. The pipe can hold as much as 50 feet. Alright, so 50 cubic feet of water. Alright, this is a mount here without overflowing. Okay. Alright, it will overflow. Okay. We're still looking at the interval T being between 0 and 8. But in this particular case, really we're not. Actually we are starting at 0, but at T greater than 8 is what they're considering here. Okay? You could do that. Alright. Water continues to flow into and out of the pipe at given rates until the pipe begins to overflow. Write but do not solve an equation. So we're wanting to write an equation. Now, and it is going to be an equation. So we know that the amount needs to be equal to 50. So we automatically should know that the amount is 50 right there. And it's saying gives the time W. So time is W. Okay, so we've got to use W. So really, all we're doing is we're saying that this is 30 again plus, and again we're going from 0, time t equals 0, to not to 8, but we are going to sometime after, when t is after 8 right there. And then of course it is going to be r at t minus d at t, dt. dt is equal to 50. And the reason you can use the t instead of x this time is you already have a w here. Other than that, if they do say t, if t is here, then you want this to be some other letter other than t. Alright, so that's the only thing that you can use it like that. And that's basically it. You want to put the initial amount here, 30, alright, added to that, alright, anytime from 0 to some time past when t is greater than 8. If you wanted to put 8 down, start with 8, you would have to go to the total amount, which I want to say is 48.543. You could do that as well, but you have to, if they want to express it in terms of W, so you need to have it like this here. And again, the amount going in minus the amount going out. Alright, it's going to equal to 50. Alright, so that is what we're looking for here. Don't leave off the equals to 50 there. It's not an equation. You got the expression. You get a point for that, but you get 2 points for making this an equation. Okay, I guess maybe if you wanted to just go ahead and say equals 20, alright, but that's okay either way. Alright, so anyway, that's that. That's what I wanted to accomplish today in this lesson. Parts C and D, an amount of water, when it talks about that amount, you do want that amount equation up there like we did last time. Okay, well, just like this right here, but it was from 0 to t there. Nothing equal here. Okay, so that's what you had to do to set that up, and then you took that derivative here, see, and then when you did that, that was r at t minus d at t, and of course on max and min, that slope that's representing the slope equals 0. Okay, you want that slope to be equal to 0. If that had been a maximum now, you would have chosen, well, we had t equals 8. 8 was the biggest. At t equals 8, we had a bigger amount. So, but we found that t, that critical number t, we'll find where those two intersect, alright, and then go from there. Alright, so make sure you understand that on any of those types of problems where you have an amount and then they're asking for a maximum or a minimum. When is this a minimum? When is this a maximum? You're going to set that table up like we did before. And then on this one here, just understand you're going from t equals 0 to sometime after that. Alright, so n equal to 50. Alright, KP the Math G signing off. Please subscribe if you would like to. If you don't, that's fine. I am going to start bringing more videos. I'm going to try to get it up to 150 videos. But if I want to go more than that, I will. Okay? That is my goal. So I have, after this one, 14 more to get to 150. Okay, well, no, it's more. Yeah, yes, yeah, 14 more. Okay, so anyway, I don't know. I'm just saying that, but I could go all the way up to 200 videos. That would be even nicer, wouldn't it? I do enjoy doing calculus. I love it. But anyway, you would, if you want to hit that subscribe button, please do so. If you want to make a comment, please do so. If you'd like to hit that like button, you see me smiling already in this nice KP cap here. All right, so enjoy this time that most of you are already out of school. Enjoy the time that you have. KP the Math G signing off. Ladies and gentlemen, have a great day.